Given the graph of f of x equals x squared, shown here on the left, find the function rule based upon the graph of g of x, shown here on the right. And we're told g of x will be in the form of a times f of the quantity x minus c plus d. Recall, if g of x is a transformation of f of x, we can write g of x in the form shown above of a times f of the product of b and the quantity x minus c plus d. Because they're giving us the form below, we know b equals 1, and because f of the quantity x minus c equals the square of x minus c, we know g of x will be in the form of a times the square of x minus c plus d. Sometimes you will also see this form where c is replaced with h and d is replaced with k, and the form is sometimes called the vertex form for a quadratic function. To determine the function rule for the transformation, let's first track the vertex. Notice on f of x, the vertex is the point 0, 0, and then on the transformed function g of x, the vertex is 4, 3. Notice the vertex has been shifted right 4 units and up 3 units. A shift right 4 units indicates c equals positive 4, and a shift up 3 units indicates d equals positive 3. We now know that g of x must be in the form of g of x equals a times the square of x minus 4 plus 3. Now, there's a couple ways we can determine the value of a. Algebraically, one way is to select a point on g of x, any point except the vertex, perform substitution, and solve for a. For example, if we select the point 6, 5, we would substitute 5 for g of x and 6 for x, which gives us 5 equals a times the square of 6 minus 4 plus 3. 6 minus 4 is 2, 2 squared is 4, 4 times a is 4a, giving us 5 equals 4a plus 3. Next, we would subtract 3 on both sides, which gives us 2 equals 4a. Next, divide both sides by 4. Simplifying, we have a equals 2/4, which simplifies to 1/2. Which means we now know the function rule for g of x is g of x equals 1/2 times the square of x minus 4 plus 3. Recall, because a equals 1/2, we have a vertical compression by a factor of 1/2. And now see if we can discover the value of a by analyzing the two graphs. Starting with f of x, let's focus on the vertex and the point 2, 4. Notice if we move 2 units to the right of the vertex, notice the function value or y value increases by 4. And if we compare this to the transform function starting at the vertex, if x increases by 2, notice the y value or function value only increases by 2. And we have to multiply 4 by 1/2 to obtain 2, which is why a equals 1/2. Again, resulting in a horizontal compression by a factor of 2. I hope you found this helpful.